This is Geometry 8.5. We're going to look at the difference between SOH, Pythagorean Theorem, and even special right triangles. We've learned three different ways to help solve for triangles. In the beginning, we learned about Pythagorean Theorem. We use this when we know two sides of the right triangle. We do not need to know any angle values to use Pythagorean Theorem. So most likely, if it has angle values, we don't use Pythagorean Theorem. If it does not have angle values, we would use Pythagorean Theorem. Remember that all of these require us to have a right triangle. So it has to have the box in the corner somewhere. There's another type of way we prove triangles, or we prove to solve for sides of a triangle, was with special right triangles. That's when we use the rules of 45, 45, 90 triangles, or the 30, 60, 90 triangle. Those are called special right triangles. We learned what the rules were. For the 45, 45, 90, we said that we had the hypotenuse equaled the leg times root 2. That was the 45, 45, 90 triangle. For the 30, 60, 90, we said that the hypotenuse equaled the short leg times 2. Or you could use the long leg equals the short leg times root 3. Those are the rules for the 30, 60, 90. (30, 60, 90) goes with those rules. The 45, 45, 90 goes with that rule. Because two angles are the same, we know two legs are the same. So we only have one formula. So we look here, we do not have a 45, 45, 90. This is 42. So it would not be appropriate to use special right triangles to solve for this. But in this case, this is a 60-degree angle. So if it has a 90 and a 60, the third angle has to come out to be 30. That adds up to 180 total. And the third way that we talked about solving for a triangle is using SOH. SOH is just a bit of abbreviation to help us remember what the sine, cosine, and tangent stands for. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And we use this to find missing angles, which we actually haven't done to this point yet. Or we use it to find a missing side length when we're given one angle and a side length. So we're going to come down to our first example, and we see that this is a 30, 60, 90 triangle. So we're allowed to use special right triangles. We could not use Pythagorean Theorem. We don't have enough information. We could use SOH, opposite over adjacent, or opposite over hypotenuse. That would be fine. But that'll give us a decimal answer. The advantage of special right triangles is we're going to get exact answers. So if possible, we want to use special right triangles. So when I look here, I notice this is, sorry for all the bells, from the 30-degree angle, across from it is called the short side. Across from the 60 is the long side, or long leg, really. And then across from the 90 is the hypotenuse. So if we're going to use the special right triangle rules, we know that the long leg equals the short leg times root 3. The long leg is 12, so we put a 12 in its spot. The short leg was the x, so we put an x in its spot, times root 3. Now to get the x by itself, we divide by root 3. And that gives us 12 divided by root 3. Now we've learned in the past that we're not allowed to leave an answer with a radical in the denominator. So we multiply by a value of 1, and this value of 1, root 3 over root 3, will help us eliminate the radical. It's called rationalize the denominator. This gives us 12 times root 3, and root 3 times root 3 gives us that exact number. It gives us the number 3. You can try that in your calculator. Root 3 times root 3 would be considered the square root of 9, and you know the square root of 9 is 3. So root 3 times root 3 is 3. The like type of numbers, neither of them are radicals. We can reduce them. So that becomes 4 root 3, and that's the value of x. So we figured out the short leg. 4 root 3. That's the exact answer. No decimal. Now we're going to use the other formula. The hypotenuse equals the short leg times 2. The hypotenuse is y. The short leg now we know is 4 root 3, and we times that by 2. The hypotenuse is twice as long as the short leg. So again, we multiply the like numbers. The 4 and the 2. Neither of those are radicals, so we call that 8. Root 3. So 8 root 3. That's the value of y. 4 square root of 3 is the value of x. We use special right triangles, 30, 60, 90. 30, 60, 90, triangle. 2 formulas we can use. This next one. Notice that this next one is not a 30, 60, 90. It's not a 45, 45, 90. And we cannot use Pythagorean theorem. We don't know 2 sides. You must have 2 sides for Pythagorean theorem. We have 1 angle and 1 side, so we're going to use SOH. It might help for you to write SOH. More times you write it, the more you're going to be able to spell it when you need it. So if you look at the 42, across from the 42 is called the opposite side. Of course, across from the 90 is always the hypotenuse. And next to the 42, next to the angle that you're given, will always be the adjacent side. We'll never use 90. We're using the 42. You always use an acute angle. This angle has to be an acute angle. So we're looking at opposite if we're going to look for the hypotenuse. So opposite and hypotenuse, adjacent hypotenuse. I'm not given adjacent, so I can't use that to solve for what I don't know. So I can't use cosine. Opposite and adjacent, that doesn't help me with hypotenuse, so I have to use sine. Sine of 42 equals the opposite side over the hypotenuse. Hypotenuse is AC. So how do we solve? How do we get AC all by itself? Well, I have to multiply by the denominator to both sides. So that gives me AC times the sine of 42. Those are going to cross off. That's why we multiplied it across. And that equals 10. So we're going to divide by the sine of 42. Sine is going to be approximately, or AC is going to be approximately 10 divided by the sine of 42. Gives me 14.9. Then we look at our last example. Notice that there's no angles given. If there's no angles, yes, there's a 90, but 90 doesn't help us. We don't know what the other angles are. So we don't know if we have 30, 60, 90. We don't know if we have 45, 45, 90. We have a pretty good guess that's not it because the pattern doesn't work. But we cannot use TOA. We don't have the angle values. So here we have to use Pythagorean theorem. Because we know two sides of the right triangle. Notice that across from the 90 is the hypotenuse. And the other two sides are just called legs. Doesn't matter which one's longer, shorter. For Pythagorean theorem, we just need to know what makes up the right angle and what makes up the hypotenuse. So the formula is hypotenuse squared equals leg squared plus leg squared. So 10 squared equals 6 squared plus our unknown side squared. So we square. We would subtract the 36 to the other side. That gives us x squared equaling 64. And we'll take the square root of both sides. That leaves us with x equals 8. Now you might remember in algebra when you take the square root you got to say plus or minus. But this is geometry. Geometry is not going to be a negative length. So we're not going to even consider the plus or minus. It's just a positive 8. Here we have a story problem. The picture is already drawn from you. There'll be cases when the picture is not drawn. So when you're reading this problem, you want to ask yourself, do you understand why the 75 is on this side of the triangle? Why the 40 degrees is this angle, and why the height has to be here? From a point 75 feet from the base of the tree. So the base of the tree is at the bottom, and a point means from it is away from it, 75 feet, so that's why the 75 feet is down here and is not 75 feet there. It's definitely not here. It's 75 feet from the base. There's a point. And its angle of elevation is 40 degrees. We learned about angle of elevation being looking up at the top. And we're looking for the height. What is the height of the tree? The up and down, the perpendicular from the ground. So from the angle they give us, I notice that this is the opposite side. This is the adjacent side. And of course, across from the 90 is the hypotenuse. I'm looking to figure out what the height is. I know what the adjacent is. Opposite and adjacent are the sides I'm working with. So again, using SOH, which sine, cosine, or tangent, SC or T, works with O and the A. O and the A is only tangent. Adjacent hypotenuse, opposite hypotenuse. So we need opposite adjacent. So we have to work with the tangent of 40 equals the opposite of that 40 over the adjacent side to the 40, the next two. So we multiply by the denominator. So 75 times the tangent of 40. I type that in my calculator, 75 times the tangent of 40. Notice that there's no other dividing needed. I just multiplied by the denominator, and that got my h all by itself. So I have 62.9, and these are feet. Last one. We have an airplane. A little hard to see. We have an airplane here. It's flying in. It's 10,000 feet above the ground. So straight up is above the ground 10,000 feet. So that's why the 10,000 feet is there. We have an angle of depression, which is when you look out from the airplane. You got to look out perpendicular. You got to look straight out. That's horizontal. You got to look horizontal, and you look at the angle coming down. That's the angle of depression. 7 degrees. But if you look at our first triangle here, the 7 degrees is not inside that triangle. You might consider another triangle. That has the 7 degrees in it. The 10,000 is going to be listed as here, because that's the height up. This is straight over, so the height up is 10,000. Your 7 is across from the 10,000. So this is considered the opposite side. And we're looking for the straight distance to the airport, from the plane to the airport. That is the hypotenuse. So again, using SOH, opposite and adjacent, adjacent's over here, opposite and hypotenuse, because that's across from the 90, we're going to have to use sine. Sine of 7 equals the opposite over the hypotenuse. What's that hypotenuse have to be? We multiply both sides by x. That gives us x times the sine of 7. That has to be 10,000. So we divide by the sine of 7. It's approximately 10,000 divided by sine of 7. That is 82,055.1 feet. We got 0.09, and if we're rounding to the nearest tenth, that would be 0.1. If we're rounding to the nearest hundredth, we look at the thousandths, and that's not 5 or bigger, so that would be 0.09. But we're choosing to round to the nearest tenth.